Here we have a number set and we're asked to find the mean absolute deviation for this number set. Well, mean absolute deviation, mean is average, absolute value is the distance away from zero, and deviation is change. So I want to know how far each of these numbers is from the mean. So first I have to calculate what the mean is. So over here for the mean, when I add these up, I get 98. And if I divide by 7 numbers, because there's 7 numbers, I get a 14. Now I want to find out how far each of these numbers is from 14. And 10 is 4 spaces from 14. 11 is 3 spaces from 14. Again, 3 spaces. This is 2 spaces. Now it doesn't matter if it's bigger or smaller. This is 1 space away from 14. Again, 14. And for this one, it's 10. And believe it or not, we're actually almost there. To find the mean absolute deviation, all I'm going to do is add up these numbers and divide by 7. And so this is these are the distances each number is from the mean. Now I want to find the average distance from the mean. So I add up all these numbers and I get 24, and then I divide 24 by 7. These added together are 24, and I'm going to divide by 7. And what I get is approximately 3.4. So the mean absolute deviation is 3.4. Now, how important this is it's a measure of the quality of the number set. And after we do a few more problems, we'll find that this number changes depending on how close these numbers are to the mean. So let's look at a number set where all the numbers are the mean. So here we have another number set. All the numbers are 7, and there's 9 of them. So 9 times 7 is 63. And I'm going to divide by 9 because there's 9 numbers. So 63 divided by 9 is 7. So over here, our mean is 7. And let's find out what the mean absolute deviation is. So how far away are each of these numbers from the mean? Well, 7 is 0 spaces from 7. All of them are going to be 0 spaces from 7. So then when I add all of these up, I get 0. And I'm dividing by 9 numbers. So I get 0. So the mean absolute deviation is 0. Now what does this tell us? Well, let's look at the number set over here. If the numbers are far away from whatever the mean is, like the 10 is 4 spaces away, then this number is not telling us what the number set is trying to tell us. The average is 14. Well, this number is smaller than the average. This one's bigger than the average. In this, every number is the average. So the mean absolute deviation being 0 is telling us that this number set is actually a very high quality number set, that none of the numbers deviate from the mean. So what we can take from this is that the bigger the mean absolute deviation is, well, the more variance that there is for the number set and the less accurate those numbers are. So this is about the average age of a second grader. So if I went into a second grade classroom and asked everybody how old they are and everyone was a 7, well, then it's a perfect number set. It's a perfect representation for that sample. Second graders is a perfect number set that gives us an accurate representation for the average age of a second grader. Now, if there are a couple 6-year-olds in this class, it's in the beginning of the year, and you have they've just coming out of first grade, well, then some of them may be 6, and you may have one student in there that might be an 8. But the perfect number set is a number set where the numbers are really close together. Let's look at a third example, and this one's going to be a really bad example. So here we have another number set, and we notice that we have a string of 5s and a single 45. And what this number set was from was somebody went in to find the average age of a kindergarten student, and the teacher was in the room. So when I want to find out what the average age of a kindergarten student is, I'm asking 8 people in the room, and one of them gives this number over here. Well, this number is very different, and it's an outlier, and an outlier is going to throw off the quality of the set. So let's find out what the mean is for this number set. So the mean, I add all these together and I get 35 and 45 or 80, and I divide by the number of numbers, which is 8. So I get a mean of 10. So I put a 10 over here, and now I want to find out how far away from 10 each of these numbers are. Well, 5 is 5 away. All of the 5s are going to be 5 away. And the 45 is going to be 35 away. So this is the original data set. This is how far the distance each number in the data set is from the mean. And then I want to find the average of the distances to the mean. When I add all these numbers together, I get a 70. I'm still dividing by 8 numbers. And what I get is 8.75. So the mean absolute deviation is 8.75. Now, what caused the error here was this was an outlier. And the outlier caused a very big error, and the mean absolute deviation is a measure of the quality of the number set. Well, when the MAD is 0, we have a perfect number set. And we noticed over here there's some variance. The greater the distance from the mean, the lower the quality is of the number set. So an outlier caused the worst mean absolute deviation, and there can be numbers extraordinarily bigger than this. But when the MAD starts getting that far away from 0, you don't have a very high quality set. So here we have a last practice problem, and I encourage you right now to please pause the video and try to find the mean absolute deviation for this data set. I'll give you a couple seconds to pause it, and then I'll review how to do it. And if you can do this, then you've mastered this material. So the first thing that we need to do is we need to find the mean. So we add these up, and what we're going to get is 86. And then we're going to divide by the number of numbers, and I have 6 of them. And when I divide by 6, I'm going to get 14.3 is my mean. Next, you need to find out how far away each of these numbers is from the mean. So 12 is 2.3 away. 13 is 1.3 away. And again here. Now be careful, when it goes to the other side, 14 is only 0.3 away. And then the 20 is actually the tricky one. If I do 20 minus 14.3, I get 5.7. And if you try doing that in your head and you got it wrong, that's going to cause an error. So when we add these up, we get 11.2. And I'm still dividing by 6 numbers. But this time when we divide, we're going to get 1.86. So we'll round that off to the nearest tenth. So I get 1.9 for our MAD. Not a bad number set.